All right, so we are diving into Unity's Universal Render Pipeline, or URP for short.
Mm.
We've got this guide, Universal Render Pipeline for Advanced Unity Creators, and it's pretty technical.
Yeah, it's definitely for, people who already know a thing or two about Unity.
Right. So we're gonna try to break it down for everyone listening. What is URP? Why should we care? And how is it changing how games are made?
Think of it as like a crash course in URP. We'll cut through the jargon so you can really grasp its power, especially if you're curious about those crazy good graphics in games these days on like everything, your phone, a high-end PC, you name it.
Okay, so the guide, right off the bat, is why did Unity even move away from the built-in render pipeline?
Yeah.
It worked, didn't it?
Well, imagine this. Trying to fit like the same outfit on, I don't know, a bodybuilder and then someone who runs marathons, that's kind of what the built-in render pipeline was like. One size fits all. But games now, they got to run smooth on everything. Powerful PCs, mobile phones. Unity needed something way more adaptable, something you could tailor make for the hardware.
And that's where scriptable render pipelines come in,
Yeah.
right? SRPs, I'll be honest, I hear SRP and I'm like, hell.
It does sound kind of scary, right? But it's all about giving devs, developers more control. So SRPs, they're like this super specialized toolkit. You're crafting how the graphics are actually made from scratch. This way, devs can fine-tune how it looks on different hardware. It's a balancing act, visuals versus how smoothly the game runs.
Makes sense. So why is everyone so hyped about URP? This guide seems particularly excited about it, even over HDRP sometimes.
The cool thing about URP is, well, its focus. It's all about performance optimization, which is huge GE, especially now with mobile gaming blowing up. Smoother gameplay, your battery lasts longer, and the graphics don't have to look worse.
Now that's what I like to hear. But okay, let's get real. What about actually switching from that built-in pipeline to URP? Is it as rough as it sounds?
Not really. Unity's got this, well, it's a conversion tool, helps you move your assets over from the built-in way. Sure, you might hit a snag or two, but the guide talks about those too.
This is the one everyone's heard of, the magenta materials thing, right?
Yeah.
Where everything goes pink.
Exactly. But, and I want to stress this, it's an easy fix, but it shows you got to make sure your shaders, those things that make stuff look like it's made of a certain material, they got to work with URP. Which brings us to another big thing. Lighting and how URP handles it.
Oh yeah, lighting. Now this is where it gets really cool.
Definitely. URP and lighting. Whole different approach compared to the built-in way. Get this. It relies a lot on real-time shadows, light baking, especially for stuff that doesn't move in your game world, and these things called light probes that pick up on all that subtle, indirect lighting. All of that together just makes everything look more believable, more immersive.
Okay, but those real-time shadows, they look amazing, but they got to be murder on your computer.
Right.
Especially in those big detailed scenes.
You're telling me that's why URP uses this really smart technique called shadow cascades.
All right, break it down for me. What are shadow cascades and why should I care?
Imagine taking your game world and you slice it up like a cake, right? Different layers. So each layer, each slice gets shadows, but at different levels of detail. Things closer to you, to the camera, those shadows are going to be crisp, high res. But things further away, the shadow quality gets toned down a bit, very subtly.
So it's all about being strategic, right? Make it look good, but make sure it runs well.
Yeah.
Which is good for those of us who don't have the latest and greatest gaming PC.
For sure. But hey, it's not all ones and zeros. What about the artist? Does URP play nice with them too?
Yeah, absolutely. And that's where these cool tools come in. Shader Graph and VFX Graph, imagine them like this. They let artists create amazing visual effects, but without having to write code. Wait, hold on. Are you saying I could make that awesome smoke effect we talked about, the one with the swirling particles, all without coding?
Yep. That's the beauty. You build these complex effects by connecting nodes, almost like, I don't know, putting a puzzle together. It's a game changer for artists, especially if they aren't super comfortable with, traditional programming. It really is a game changer. It lets artists work way faster, try out different ideas, because it's all visual.
That's wild. It's like URP is making those lines blurry, between the tech stuff and the art stuff in game dev.
Totally.
But okay, before we get lost in a cloud of awesome particle effects, the guide also talks about some pretty hardcore URP stuff.
Right.
One that caught my eye, camera stacking. What's the deal with that?
Camera stacking. Oh, it's super powerful, especially in URP. You're basically taking multiple camera views and you combine them into one render.
So you have your main view, and then a smaller window shows a different angle. Kind of like those security camera feeds you see in some games.
Yeah, exactly. Think about it. How would you make it so a character, like, looks through binoculars in a game?
Oh, right, yeah.
Camera stacking lets you render that zoomed-in view from the binoculars right on top of the main view, and it's seamless.
That actually makes a lot of sense. So URP makes that whole, like, complex camera stuff easier.
Way easier. It streamlines it.
Yeah.
Compared to that old built-in render pipeline, it's way more efficient for, those multi-view situations.
It seems like, I don't know, every single thing we talk about with URP, it always comes back to, like, make it run better, optimize, optimize.
It's the name of the game, right?
Yeah.
The guide, it really drives that point home. You're squeezing every last drop of performance you can, no matter what hardware you're on.
Okay, so it's efficient, it's artist-friendly, it gives devs, like, granular control. There's got to be a catch.
Right.
Nothing's perfect.
Of course, there are always trade-offs. The document does mention some potential challenges.
Oh, here we go.
Like with the forward renderer, there are limits on how many real-time lights you can have.
Light limits. Okay, back to high school physics class. What does that even mean for, like, actually making games?
Okay, so the forward renderer, it's blazing fast, super efficient, right? But there's a limit on how many lights it can handle for each thing, each object in your scene. For most smaller games, or if the lighting's simple, not a big deal. But imagine a giant open world game, hundreds of lights, and they're all changing.
Yeah, okay, I see where you're going with this.
That's when you hit those limits. Developers have to, be mindful of it when they design their levels.
So optimization isn't just about making things look amazing, it's also knowing what your tools can actually handle.
100%. And to help with that, the guide also gets into some advanced techniques and tools.
Like that submit render request API you mentioned before. That one sounds like, whoa. Explain it like I don't know, explain it like I'm 5.
Okay, so basically, submit render request gives you, the developer, super fine-grained control. You decide when and how things actually get rendered on the screen. It's like, imagine taking a picture, a snapshot, of what the game looks like at a specific moment. Might not sound that exciting.
Right.
But it opens up so many doors.
Like what?
Custom post-processing effects, which is how you get those really cool, stylized looks.
Right.
Advanced debugging, so you can find and fix problems faster. Even more creative ways to play with the final image after it's rendered.
Huh. It's kind of like what we were talking about before with the shadow cascades, right? URP is all about being smart about performance, but not making things look worse.
You got it. Another perfect example, occlusion culling.
Okay, I'm going to need you to
All right.
explain that one.
So remember how shadow cascades, they optimize the shadows based on how far away something is?
Yeah.
Occlusion culling, same idea, but for entire objects.
What do you mean?
Okay, picture a super detailed scene, right? Trees, buildings, furniture, all that. Occlusion culling is smart. It knows which objects are completely hidden behind other things from where the camera's looking.
So if, like, my character's behind a wall, URP's like, nope, don't even bother drawing them. No one can see them anyway.
Exactly. It only renders what it needs to, saves a ton of processing power, which means more resources for other cool stuff, like those real-time effects.
That's super clever. But are there any downsides? Like, what happens when my character walks out from behind the wall? Do they just, like, pop into existence?
$1 million question. It's a balancing act. If it's not done right, occlusion culling can cause, weird visual glitches, things appearing and disappearing.
Yeah, that wouldn't be good.
But when it's done well, you don't even notice it, and that's the goal.
Totally. I always say the best improvements are the ones you don't even realize are happening.
For sure. And to fine-tune all of this, the guide talks about 2 amazing tools built right into Unity, the Frame Debugger and the Unity Profiler.
All right, so tell us about these tools. What makes them so important for URP?
Okay, the Frame Debugger. Think of it like X-ray vision into how your game is being drawn. You can walk through it step by step, frame by frame, and see exactly what's happening, which draw calls are being made, how they impact performance. Super useful for finding bottlenecks and really optimizing things.
And the Unity Profiler. That one's different.
The profiler, that's your big picture. It's tracking CPU usage, GPU usage, how much memory is being used, even audio processing.
Wow.
Gives you a full understanding of how your game is performing overall.
So the Frame Debugger is for those really precise optimizations, and the Profiler is more about seeing how everything works together.
You got it. And to see URP in action, really see it, the document highlights this URP 3D sample project.
Ooh, I love a good example. What's that all about?
Think of it as a URP playground. It has 4 different scenes, and each one shows off a different part of what URP can do. You've got the garden, which focuses on stylized PBR rendering, lots of lush plants.
Nice.
The oasis scene, that one's going for photorealism and shows off what VFX graph can do. Then there's the cockpit, which is all about VR. It's got custom lighting and a really cool toon shader effect.
A toon shader? What, like cell shader?
Yeah.
Yeah, that's cool.
And finally, the terminal scene. That one's like a hub, connects the other 3.
Wow, that's a lot.
It's a URP buffet. Each scene is like a mini masterclass in a different part of the pipeline.
Nice.
And the best part, it's not just about making it look pretty. It's designed to run on different hardware right from the start.
Scalability.
Yeah.
Making sure it runs well no matter what you're playing on.
Exactly. And the document even dives into how they optimize the mobile version of the project, which is where it gets really interesting.
Okay, hit me with those mobile secrets.
One of the biggest ones. They actually use deferred rendering on mobile.
Wait, really? I thought deferred rendering was more for, like, powerful computers.
That's what most people think. See, deferred rendering, it can be more demanding overall, but it shifts a lot of the work to the GPU.
The GPU, that's the graphics card, right?
Yep. And in a lot of newer phones and tablets, the GPU is surprisingly powerful, sometimes even more powerful than the CPU.
Huh. So you're saying they use deferred rendering on mobile because, even though it's more complex, it actually takes advantage of how good mobile GPUs are these days.
You got it. It's a perfect example of how URP lets you tailor the rendering to the hardware, even on mobile devices that are, pushing the limits of what you can do with real-time graphics.
That's pretty wild. Like, they had to rethink how to squeeze out performance because the hardware was so different.
Yeah, and this document really drives home this point. URP isn't just like a bunch of new features. It's a whole different way of thinking about making games. It's all about, like you said, efficiency, scalability right from the start.
Totally. But let's bring it back down to earth for a sec.
Okay.
What does all this mean for someone who just wants to, play games?
At the end of the day, that's what matters, right? For players, it means a better experience, plain and simple. Think about it. Smoother gameplay. Even with awesome graphics, your phone battery doesn't die as fast, and more games that'll actually run well on your device, even if it's not top of the line.
Now, that's what I'm talking about. It's like a win-win.
Exactly. Devs, they get to be more creative because the tools are more powerful, and they can reach more players. URP is kind of like leveling the playing field, Even smaller studios can make really impressive games now.
We've covered a ton of ground today, that's for sure. From the nitty-gritty details to, like, the big picture of where game dev is going. It's been a ride.
Hopefully now people have a little more, appreciation for how much work goes into making these worlds, these games that we get to play.
For sure. So as we wrap up this deep dive into URP, any final thoughts for our listeners? Something to think about as they fire up those URP games.
The document kept coming back to this idea of performance, right? How URP is all about squeezing every drop out of your hardware. So next time you're playing a game and it just looks incredible, ask yourself, how much of that is because of URP? How do they make it run so well?
It's kind of mind-blowing when you think about it. It's like as the tech gets better, the limits on what devs can do, they just kind of disappear.
Exactly. URP is a huge step towards that future of gaming where, amazing graphics and creativity aren't limited by the hardware. So yeah, next time you're blown away by a game, remember URP might be the unsung hero behind it all.
And on that note, we'll wrap up our deep dive into Unity's universal render pipeline. We've gone from complex technical stuff to real-world examples, and hopefully got you excited about what's next for game dev. Until next time, keep exploring, keep learning, and most importantly, keep playing.